The POTT pilot-aided scheme stands for the Permissive Overreaching Transfer Trip Scheme. Like the other pilot-aided schemes, it is used to speed up the clearing of faults that occur in the end zone of a transmission line. Again, a communication channel must be provided between the two relays for the POTT scheme to operate. In the POTT scheme, the remote distance relay speeds up the tripping of an end zone fault by sending a permission to trip key from the remote relay to the local relay under two conditions. The first condition is when the remote relay detects a fault occurring within its overreaching zone 2. This is where the expression overreaching comes from in the term permissive overreaching transfer trip. The second condition under which the remote relay will send a permissive key is when it detects that ground current is flowing in its forward direction. Therefore, the remote relay's forward negative sequence directional overcurrent element, or its forward neutral directional overcurrent element's operation, will also cause the remote relay to send a POTT key to the local relay, in addition to the overreaching Zone 2 pickup flag. In the POTT scheme, the local relay POTT logic will only cause the breaker to trip if it gets the POTT key and the local relay has detected a fault within its Zone 2 area of protection, or it detects that ground current is flowing in its forward direction if this function is enabled. As a result, either the local relay's forward negative sequence directional overcurrent element or the forward neutral directional overcurrent element, as well as the picking up of a Zone 2 fault, will cause the POTT scheme to trip the breaker once it has received a permissive key from the remote relay. Any combination of the two reasons the remote D60 sends transmit keys and the two reasons the local relay identifies a fault will isolate the transmission line and verify the fault is located on the transmission line we are protecting. As shown in Diagram 1, if Zone 2 of both relays identifies a fault, it is a clear indication that the fault is on the transmission line, so both relays will trip their respective breakers. In Diagram 2, the remote Zone 2 indicates that the fault is located to the left of the remote relay, and the forward flow of ground current, as seen by the local relay, indicates that the fault is to the right of it. Therefore, the fault is on the transmission line, and both relays will trip their breakers. In Diagram 3, the forward-flowing ground current of the remote relay and the Zone 2 picking up on the local relay is a clear indication that the fault is on the transmission line, and so both breakers will be tripped. Finally, in Diagram 4, the direction of ground current detected by both relays is flowing into the transmission line, which is again a clear indication that the transmission line is faulted, resulting in the tripping of both breakers.